Alright, so this is just a continuation from the previous video. I'm just going to go through the mark scheme. And yeah, that's it really. So, the first question, chlorine has a low boiling point because the forces between the molecules are weak. Explain how these forces arise between molecules of chlorine. So I said unevenly distributed chlorine atom. There's a lot of answers they had for this first one. So it's like, it's random movement of electrons in one molecule, unevenly distributed chlorine atoms lead to an imbalance. So it leads to an imbalance of electron density in one molecule. That's the mark. Imbalance. Oh, mention that there's an imbalance in electron density in one molecule. Mark there. Random movement of, unevenly distributed in one molecule. A temporary dipole is formed in one molecule. So induces a dipole in local surrounding CO2 molecules. Local surrounding neighboring CO2 molecules. I put neighboring here just in case. But local surrounding molecules, they get that what you're trying to say there. And these temporary dipoles attract. So there's a leading to a partial attraction between the partially negative and partially positive atoms. Partial attraction, temporary attraction. You can get the marks of that, forming a temporary dipole. If you said, even when you said temporary dipole bond anyway, so 3 marks there. That's just correct. Low concentration. Yeah, just saying kills bacteria is enough. So kills bacteria is enough here. CO2 plus 2 NaOH goes from NaClO plus NaCl plus H2O. DA, I already explained why it's DNA when I did the actual video, so I'm not going to explain there. If you want to understand why it's DNA, go back to the previous video. Question 4. They allow the ionic equation. So the actual equation is 2H2SO4 plus NaBr goes from Na2SO4 plus SO2 plus Br2 plus 2H2O. But they said allow the ionic equations forming NaHSO4. So 2Br minus plus H2SO4 plus 2H plus goes to form Br2 plus SO2 plus 2H2O. Doesn't matter how it's arranged, but you know it's there. And then you said you're forming an orange brown. So they allow fume. Actually, I like that answer there. Orange slash brown fume slash solution. I've said fume, but if they allow either fume or solution, because technically bromine is half gas, half liquid, so they allow orange brown fume, or you can say or even solution if you wanted to. Yeah. So, but either way, 2 marks there. Alright, so this is a bigger, longer, hard question. So, nitric acid removes hydroxide slash carbonate ions. You actually have to say which ones it's in brackets here, but it removes such ions. They could cause. They may give other precipitates with silver nitrate. So, removes carbonate impurities reacting with the silver nitrate, giving a false positive result. But I haven't mentioned the word precipitate. It would, but I should have mentioned the word. Nitric acid to remove carbonate impurities that could react with the silver nitrate to produce a precipitate. So I wouldn't add the mark here, but I had to say to produce a precipitate. Can you see that? Let me try and 1 second. Yes, I think I made the whole bear. Yes. Good. So Yeah, I would have got the mark here for saying that it's just used to remove ions that may give other precipitates, but I just had to say give other precipitates instead of just saying to prevent it from reacting with the carbonate ion impurities. So I'm not going to give myself a mark for that. But silver nitrate produces precipitates with chloride/halide ions. Silver nitrate is used to test which color precipitates form that determine the halide present. Yes. And then you get a mark for the correct ionic equation. So AgP silver ion. So Ag plus Cl minus goes from AgCl, and Ag plus I minus. So you could give either or really, or you could even say Ag plus X minus goes from AgX because it's still a general term for those type of ions. For silver ion reaction with a halide because X can be represented in the halide. NH3 dissolves AgCl. So the precipitates are difficult to determine. Dilute ammonia dissolves AgCl. Yes, that's there. You don't have to actually say the way you don't have to say leaving yellow, AgI. But I have it anyway. And then saying doing this ionic equation here. So this last one here kind of confused me because it should have been. The Cl minus is more of a spectator ion in this reaction, so I don't really see the point of writing the Cl minus when it comes to this, but yeah, I guess that part is wrong. I have to take on the chin. AgCl plus 2NH3 goes to form this part here, the silver diamine part is right, but plus a Cl minus. But it did say ionic equation, so I did kind of conflict that what I was saying there, but yeah. Anyway, we got 1, 2, 3 out of 5 marks here. I'm not gonna tot this up at the end because I just don't really care about my overall mark. But I'm just trying to show you when you're marking, be very strict with the way you're marking. Because I thought I got this 100% correct, but small things here like saying to produce precipitate because you're trying to prevent the nitric acid is used to remove the carbonate impurities reacting to silver nitrate that would have given the precipitate. As you're trying to prevent it from forming a precipitate. And then this one here is a bit dodgy, but you can already see my structure here, right? The bullet points help me out when I'm writing these questions. If I just did it straight away, it might be a bit it'll be a bit harder to follow, but when you do it in bullet points, it's much easier for the person that's marking your paper to see where they're going. And imagine you're an examiner reading through your own paper, right? I know it's a bit hard to see your own mistakes, but that's how you want to make it. Doing bullet points are much easier to see, right? So that's how I would do it personally. And then this one here, to kill bacteria. You know what? Should I count out my marks at the end? You know what I would. You know what I will. I will. 3 for 5. And then that's just 6 there. Yeah, okay. Alright, I'm trying to go through this as quickly as possible now. So, in low concentrations, chlorine isn't toxic. So the benefits outweigh, look at this part, benefits outweigh the risk or benefits outweigh the drawback. But more importantly, the low concentration of chlorine isn't toxic. So, and that's what causes it to say that the benefits would outweigh the drawbacks. CO2 plus H2O goes from HClO plus HCl. And here's just doing, you should be able to do this by now. 6H, yep. Putting that together, 6I minus, 6H plus, H2SO4, 3I2S, 4H2O. Here, H2S or SO2 would have worked. Again, if you want me to explain why, again, the previous video was explaining why, if you need help with that, in understanding the answer. But I've already gone through in the previous video. This is just me going through the mark scheme now. To ensure all the halide ions are removed from the solution. To ensure all the halide ions are removed from the solution. To ensure all the halide ions precipitate out of the solution. So to make sure all halides in the solution precipitate out, yep, I'd give a mark for that. Moles, 1.34 times 10 to the power minus 3. I made any mistakes so far? No. E, 0.201 grams, yes. And then this is anywhere between, if you get anywhere between 66.5 to 68.3, that's the correct answer. The reason why they give the range, the actual answer that is just, that's correct, is 66.5, but they would allow any answer between 66.5 to 68.3. The reason why is because there can be rounding errors, especially here. So they just, or at least in the previous one, so they will allow it really, but yeah, you should get really 66.5. Yeah, 12 marks there. 6 is B, D. Colorless, allow no visible reaction or no observable reaction really. Next one is white misty, steamy or white fumes or white misty fumes. That's fine. NaCl plus H2SO4 goes from NaHSO4 plus HCl. Yes. Acting as a base. C, 2Br minus plus, you can use the normal equation or the ionic equation. I've used the ionic equation here. So 2Br minus plus 2H plus H2SO4 goes from SO2 plus Br2 plus 2H2O. Yes. Then it's just saying that bromine oxidation state changes from -1 to 0 and it's being oxidized. And SH2S, the sulfur in H2SO4 change oxidation state from +6 to +4, so it's being reduced. So D says it can be a yellow or orange solution. I've said brown/orange solution forms. I'm gonna not accept that because it says a yellow or orange solution. So I'll cancel that one out there. Yeah, be strict. Even if you think that the examiner would, if you think a teacher would give this, or maybe the examiner might give this, you try and be strict with your answers so you kind of get an answer that's as close as possible to the mark scheme. The sad thing is about AQA, right, is that your answer has to be very specific to the mark scheme itself. Even if you think that the answer technically is the same or the right answer, you can't think like that. You have to just give an answer that's specific to the mark scheme. It's a lot different when you leave school and you go to higher education, but you know, the mark schemes can change a bit more, but AQA are very strict about this is the only way you should write it down. But anyway, doesn't matter here. So brown orange solution forms, I wouldn't give myself a mark for that. But I will give myself a mark for the next part, which is CO2 plus 2Br minus goes from 2Cl minus plus Br2, 8 marks here. 9 is C, 10 is A, so C, A, C, A. I'm not going to explain why. You already know. I mean, look at the previous video. NaCl plus H2SO4 goes from NaHSO4 plus HCl. It says proton donor, but an acid is a proton donor. So even says here allow bronze-Lowry acid, or you can just say allow acid because the bronze-Lowry part is in brackets, but it isn't acting as a bronze-Lowry acid anyway. But these two allow, just saying allow acid. Where did I just push me that up? Oh, yeah. Yes. This just push me up. Yeah. Sorry, it just got lost a little bit there. B. So now it's gonna say. I mean, you can just do. I mean, you already know it's 2Br minus plus 2H plus H2SO4. Yeah, it's a recurring thing. They keep using that one there. But anyway, brown gas or brown slash orange. Do not accept yellow solids. Ignore fizzing and misty fumes. Brown gas or brown fumes or orange gas or orange fumes. Brown slash orange fume being formed. Yeah, yeah, I get that. Acts as an oxidizing agent. Yes, this is a redox reaction, so it is acting as a oxidizing agent. +5 and -1. I should be careful when I'm writing the +5. You want to make it look like an S. Be careful when you're doing this. Some examiners would know that's clearly a +5, but yeah, just be careful when you're rushing it. +5 may probably make this more clearly a -1. Examiners aren't that stingy, but some, you never know, some of them probably are a bit stingy. So yeah, +5 -1. Where is this one? So D, right? Yeah, D. Chlorine is being oxidized and reduced at the same time. So allow undergo disproportionated. I said chlorine is being disproportionated, which is when it's being oxidized and reduced at the same time. Next one is silver bromide, silver carbonate, CO2. I went through this during the last video. I'm gonna stop saying it. You already know. I'm not gonna go through any of these questions in detail because I've already said that in the previous video when I was going through the paper. Yep. Question 14. So these type of questions, they mark you based of which band you're in. So being in band 3 or band 1 is just between 1 and 2 marks, where 2 stages of are covered, but the stages may be incomplete or may contain inaccuracies. I'm going to assume that you guys kind of know this because this kind of comes up quite a lot. You kind of know how the bands work, but band 1 is like you've barely covered 2 stages. Band 2 is that you covered, all stages are covered, but the stages may be incomplete or may be containing inaccuracies. So stage 1, 2, and 3 are covered, but level 3 or band 3 is all stages are covered and each stage is generally correct and virtually complete. Answers is communicated currently and shows a logical progression from stages 1, 2, and 3. So let's just go through all stages here. So stage 1, suggested tests. So covers 2 tests with matching observations, conclusions, and equations. Right, so add name acid to all 3. I said add nitric acid to all 3 test tubes. So 1A is complete. I'll write actually here. Right, 1A, 1B, add water to make all into a solution. I haven't done that one. I haven't said that one. 1C, add silver nitrate. So converted it to, then add silver nitrate, and we said that there. So it's add silver nitrate. 2A now. So that was the suggested test, and then stage 2 is expected observation. So the conclusion for that, silver carbonate will fizz with an acid. So silver carbonate will produce an effervescence of gas as well as fizzing with reacted nitric acid. 2B, silver chloride will give a white precipitate. So silver chloride will form a white precipitate. 2C, silver fluoride shows no observable reaction, so there's no visible reaction, no precipitate formed. So silver fluoride, no observable. Sodium fluoride will show no observable reaction when it's reacted with the nitric acid as it's being converted to silver fluoride, and that would instantly get redissolved again. I take that. I thought the light turned off because something happened with the. I think my phone's just overheating. Anyway, hopefully you can still see this. Yeah, I think you can still see that, right? Can you still see that though? Okay, let me just 1 second. 1 second. Hopefully you can see that a lot better now, but I don't think you can see like a whole lot better, but oh well. You're gonna have to just firm it. You're gonna have to just firm it. So 2C was covered. Yes. Additional incorrect observations would lose a point. I don't think there's any additional observations that we said in here, so no. 3A were just the equations, so silver carbonate plus 2HNO3. They said the state symbols was matched, but I didn't see it here, but the carbonate would be solid. Aqueous acid, 2 silver nitrate plus CO2 plus H2O is correct. So 3A is correct. 3B, 3C, 3B was what? Silver nitrate plus NaCl. So silver nitrate plus NaCl goes to form AgCl plus silver nitrate. Sorry, plus sodium nitrate. Yes. And the correct state symbols. As far as I can see here, these are all the correct state symbols. Silver fluoride would be aqueous because I mean this equation here is just disregarded in it because you're not really going to form silver fluoride. That just redissolves back into silver ion, fluoride ion. So you wouldn't really need that, to be fair. So I'd give myself 6 marks on this because only missing out on 1B. If you missed out on 1B and also 1B and 2B, maybe be 5 marks, but only missing that out, and it's not quintessential to the answer being correct, you can give yourself 4 marks there. If I'm wrong, if some teachers out there saying you're completely wrong for saying that, or if any teacher that's actually reading this, or anyone that's coming out and said you're completely wrong, leave a link leave a comment on the video, tell me why I'm wrong. But as far as I can see, that's how I understand the marking system to work. But yeah, don't at me too much. 15 is C, 16 C, 17 C as well, 18A. All right. Reason how the levels work. I'm just gonna go through it here. Okay, so indicative chemistry content. Boiling tubes are likely to be too small for 50 grams. Solid plus acid, and using mediums as 250 milliliters baking soda. So I just pretty much said, yeah, I actually just said what's here. So too small 50 grams, solid sample, nitric acid. So with the solid sample plus the nitric acid, so that's just the mark there. I mean, this isn't how you do it, but it's obviously I don't have to. This is in bands, but yeah, I'm giving a tick that represents the points I said there, and I'll look back at the end and see what bands I fall into and how much marks I should be awarded. 250 milliliters. S. Silver nitrate will form soluble silver. So nitric acid will form soluble. I didn't mention the fact that it's soluble. I said nitric acid will form silver nitrate, but I didn't mention that it's soluble, so I don't know if I'll get the mark for that. But I mean, but I did say, that nitric acid will form silver nitrate, therefore we can't obtain the maximum yield of silver chloride, so we should use HCl instead. Now using HCl instead is a point that they would allow. And saying the max AgCl isn't obtained, but I think soluble is quite quintessential to this statement here, mentioning that it's because otherwise it doesn't really give the point. It doesn't really show why nitric acid would not be the best acid to use here. So I wouldn't give myself that marking point. Or you could say using an excess. add acid until normal, so you could use an excess. So you could add excess HCl, I guess. Alright. Although I did say this though, method doesn't say how much acid should be used, and I said the method fails to give a measurement of the volume of acid required for the experiment. So you could give yourself that marking point actually. Alright, so decanting means solid is wet. So decanting insinuates a contaminated solution of AgCl. So contaminated. Loss. I should have mentioned here that AgCl is lost. And instead use filter when and then wash with distilled water. Instead filter paper and then wash with distilled water to remove soluble impurities. So I'd give that, but overall I think it's a 5 because if I've mentioned all 3 stages, I've covered them, but minor things have prevented me from getting the full 6 marks. So I'd give myself 5 out of 6 marks there. Again, if there's a teacher that's watching this video or some student that thinks that I may have made an error in that marking, leave a comment in the description, sorry, and explain why you think that. And yeah. Okay, so next one is just if you get this part right, just that part right, that's 2 marks. So SOCl2 is number 1, ICl is number 2. That, I mean, obviously I didn't just use this to say my answer, but I did explain it in that way. So if you get that part, that's already 2 marks. Shouldn't do it like that, just. But yeah, M1 was covered. SOCl2 forms strong ionic bonds or strong electrostatic forces of attraction between opposite ions. So SOCl2 has the highest melting point. It has ionic covalent forming a giant ionic crystal lattice with strong electrostatic forces of attraction between the positive SO2 plus and negatively charged Cl minus ion. Lattice so many strong bonds to overcome. I didn't mention that part, I don't think. Well, I mentioned that as it's a giant ionic crystal lattice, but I didn't mention the first. A giant ionic crystal lattice with many strong bonds to overcome. Again, the purpose of this video, right, is that you understand, like, you look at it. I'm trying to represent what you would be like in your exam. Trying to show you how I would do it, right? Because obviously you can just do the right answer, but like, because I've noticed myself, I think I'm saying the right things, but I miss out the small things, and this is what people need to look at whenever they're doing these questions. Like, you know the answers, you know how to answer these questions, you know that you look at this and it's like, I do know that actually that's not something new to me, but you forget to put them in because you're like me, and you'll miss out on easy marks because you're rushing through your exam, or you fit into another category where well, you just don't know the content, or you just don't understand the content, or something like that, or it's not really understanding content, but you just don't know how to, you know what you want to say. There's 2 types of people. There's people they rush through the content, so they rush through the paper, and they think they've answered it in the way that they thought they have, and they realize back afterwards that they've missed out on easy marks because they didn't specify every single specific point. And some people that know what they want to say, but they don't know how to say it. The second one takes a bit more help. I'm trying to help people that this last video here, my previous video was for helping the second type of person that doesn't know how to say it. That's me going through the paper. This video is more to help people that have they know the answer, they know how they want to write it, but they forget about these things when they're writing it, and this is important to see. And you can see like me right here. things like that, saying many strong bonds to overcome. I know that, and I always usually write that, but I've forgotten to write here because I've gone through all this, and that's why it's important to look over your paper. Last night I wasn't all bothered to look over my paper because pure laziness really, but you should go over your paper and you should read back your answers and say, is there anything more that I want to? If you're going through paper, always go through paper. Say to yourself, is there anything more that I want to add to this paper? Is there anything more I can give to this answer? That's always what you should do when you're looking through questions. Say, SOCO2 is the highest most important as is an ionic compound forming a giant ionic crystal lattice with many strong bonds that requires a lot of energy to break. Due to the fact that there's a strong electrostatic force of attraction between the positive or between the oppositely charged ions. That's what you should be thinking. I was like, why did I mention this part about the bonds? Anyway, I'm gonna continue the video now, but I just want people to understand that whilst I'm going through the paper, that just make sure that you're not going too far, especially if you have time at the end of the exam. Think, why do I have so much time left in the exam that I should spend? This paper is meant to be 2 hours long, and I still have a lot of time left for this paper, for example. You know what I mean? So why is that? That means that probably if I've gone extremely quickly, if I miss things out, why are people still writing? These things come up in your head, and just say, I've still got more to write down. That's all it is really. But I'm gonna stop talking now because probably someone got bored. Probably someone skipped this part of the video right now. I'm just gonna go straight through it. Anyway, iCell is a dipole-dipole bond between molecules which are weaker than ionic bonds. So second highest melting point due to some covalent character forming weaker partial dipole-dipole interactions. I probably should put that to do not disturb. BR2 has van der Waals forces between molecules which are weak, so weaker van der Waals intermolecular forces here, so 5. CO2 plus H2O, okay, that's fine. Kill bacteria. Chlorine in high concentrations is toxic, so some people suffer wasteful using washing. Can reactive organic compounds produce harm substances? Allow is potentially toxic if it's over concentrated. So chlorine in high concentrations is toxic. Say that, or you could say that it can react with organic compounds to produce harmful substances. When it reacts with organic compounds, it usually produces carcinogenic compounds, which are just cancer-causing compounds. But anyway, cancer-causing compounds are harmful anyway. 3 marks for that. This equation 6Br2 plus P4 goes from 4P Br3, or was it phosphorus tribromide? It says pyramidal shown in diagram, but the name and the shape isn't needed. So yeah, I said this was trigonal pyramidal. This is what it would look like. They haven't shown it. I don't know why I haven't shown a diagram here, but that's what it should look like. And it's obviously 107 degrees. They allow anything between 100 and 108 degrees, but really 109.5 degrees minus 2.5 to give you 107 degrees. Next one is a tetrahedral compound shown in the diagram. The name isn't needed. I always make sure to put the brackets and show us the charge because this is a positively charged compound here, and it's 109.5 degrees. So just have that part there. How many? Yes, 1 less marks. That's 13. Hopefully we're nearly there now. 16, 2 more pages left. AA, but no car service, and then NABR. Right. So this is I think this is one thing they don't allow the usual ionic equation that I did before. I don't know why, but yeah. So that is the ionic equation that you're meant to use. So 2Br minus. I don't know why they use that one in particular. There's no H plus, just H2SO4 goes to form Br2 plus SO4 2 minus, or Br2 plus SO4 2 minus plus SO2 plus H2H2O. I guess it's because it's sodium bromide and not bromine. Maybe that's it. Maybe that's it, really. Yeah, bromide ions are larger than chloride ions and loses an electron more easily. Bromide ions are larger than chloride ions, therefore bromide ions are more easily oxidized. I said they're better. Here's now a problem, because I said that they're better reducing agents, which means they're better at being oxidized. But that's not the same thing here. So again, between the nucleus and outermost electron, no, it's sad because that is the same thing really, but I can't really give myself a mark for that really. So Br minus ions are more easily oxidized. Let's say, yeah, our AQA are very specific. You have to say exactly what they want to say, and I'd advise you to do exactly what they say, because you can't really fight it really. It is what it is. But yeah, because this is the way they say specifically, Br minus ions are how does you know that part? More easily oxidized are more easily oxidized. So I only got 1 mark really from that. Last 2 questions. I'll do this last one here because it's just an easy one here. To CO2 plus 2OH minus equals to form OCl minus plus Cl minus plus H2O. OCl minus is +1, Cl minus is -1. Okay, so cool. Add nitric acid, add silver nitrate. So add silver nitrate to the mixture to form precipitates. So silver salt precipitates AgCl and AgBr. Write the 2 equations down. How many marks is this? So the ticks don't represent marks. They're just the marking points here. Add excess of dilute ammonia. So then add an excess volume of dilute ammonia solution to the mixture. The silver chloride precipitate will dissolves AgCl only. AgCl plus. I didn't write that equation down. That's my bad. I should have wrote that equation down. So AgCl plus 2NH3 goes to form AgNH. See, so I mean, I'm rushing through, because I know myself, right, and I know that I know that I should write an equation for that, because it does say write the equations for each step. But because I rushed through and I just saw the end of this paper, and I thought nearly done, I missed out on opportunities like that. So make sure to go through a paper at the end. Because in the other videos where I go through a paper at the end, I usually gain more marks. But this time I didn't, and this is what can happen if you don't go through a paper, especially if you have time, and especially if you're someone that likes to rush through. Filter off the remaining silver bromide precipitates. So use filter paper to filter out the silver bromide, and then wash with the silver water, and then pat dry. I mean, I give myself 5 marks because the iron equation was quite important there, and didn't do that, so 5 marks there. So 5, 6, 7, 8. All right, then let's add this all up together, then let's see how much I ended up getting. Plus 13. Alright, so hopefully these videos were helpful to you. Yeah, that's all I can really say, really. This is the last video that I'll be making for AES content, really. 90. Alright, 90 out of 98. I mean, that's still pretty good, to be fair. 90 out of 98, I'll still take that. Especially on a tired night. Yeah, but this is the last video that I'll be making on AES content. Unless it's something that's really I messed up on, that didn't come out. So, but yeah, this would be this is it. And the next video I'll be making would be just continue with A levels. I already started that. 91.8%. All right, see you.